Welcome back to another math lesson. Today we're going to talk about solving one-step equations. Our learning target is that I can solve one-step equations. Before we can learn how to solve one-step equations, we need to actually know the rules for solving any kind of equations. Okay? And before we can do that, we probably should know what an equation is. Up until this point in the year, we've worked with expressions. So expressions are math sentences that don't have an equal sign. So we've just had like 3 plus 5. Okay, so now we're actually going to put 3 plus 5 equals 9 and a variable. Okay, so we're going to have an equal sign in our sentences now. So we're putting that equal sign in there, and that is where our expression changes to an equation. So the expression has no equal sign, and an equation has that equal sign. So equation, equal sign. All right. So now if we look down, you can see that there are 3 rules. There's a goal and 3 rules for how you can solve equations. Notice it says for solving equations, not solving one step, not solving a specific number of steps. This is for solving all equations. So what I want you to do is look at the word bank here at the bottom of my screen. You should have it on yours also. This word bank fills in the goal, step 1, step 2, and step 3. I want you to pause the video and try and fill this in. I kind of gave you a little bit of a hint inside of the word bank to give you a little bit of help. Go ahead and pause the video now and try and fill this in. All right, so the very first line says, goal, to find the solution or solve an equation, the variable must be isolated. That means that our variable needs to be positive, single, and alone. Okay, so she needs to be all by herself. Okay, and she's happy about it too. Okay, so our variable needs to be all by itself, has to be positive, and there can be nothing else attached to it. Okay. All right. So then step one, this is step 1 right here. Step 1 says equations are like scales. Think like old school scales, like in science where you had to keep them balanced. There's a picture, an example right there in the middle of your paper. Whatever you do to one side of those scales, you have to do the same thing to the other side to keep it balanced. Equations are exactly the same. If you do something to one side of that equation, you have to do the same thing to the other side of that equal sign to keep it balanced, or your answer is not going to be the same. It's not going to be correct. So if we look at this scale, and we can currently see that there are 3 of these red circles. So if we come over to the other side of the scale and we see 1, 2, 3 red circles, well, now we can see for ourselves that this green square right here, or this green rectangle with the X on it, that means that because this scale is perfectly balanced, which you can tell because it's flat, it's not tilted one way or the other, that means that this green square with an X must equal 4 circles. Okay? What else that means is if we decided that we wanted to take away one of these circles, we can take away one of these circles, right? But if I take one from this side, then I have to also take one from this side. If I want to take 2 away from one side, I have to take 2 away from the other side. And on and on and on. So step 2, that's this one, says to get the variable alone, add or subtract to make a 0 pair. So what that means is if I wanted to get this x, this green x right here, right? If we don't know what this green x is, if I want to get it all by itself, how many of those red circles do I have to take away? I have to take away 3 red circles. Right now I have positive 3 red circles. So I would need to do the opposite of positive 3. So I would do minus 3. But if I do it to one side, I have to do it to the other side. And it's really nice for me personally. I like to actually pretend to draw a scale. So when I write my equation out on a piece of paper or on our computers now, I actually, when I have my equal sign, I actually draw a line down the middle to remind myself of the scale. So I'll have my equal sign on paper, and then I will draw my equal sign right down the middle to remind myself of the scale. And then I know that if I do this problem, positive 3 minus 3, that gives me a 0. And then if I take 3 of those red circles and I take away 3, I can have another 0 pair, and I'm just left with however many I have left, which in this case is 4. So now I know x is 4. Another way to show that the green x is equal to 4. And last but not least, step 3. We have to isolate the variable, multiply or divide to get positive 1. So to get that variable all by itself, finally, remember, positive, single, and alone. We can multiply it or we can divide it by a number to get that positive 1 with it because we just want one of those variables. And then that variable will be all by itself. Okay? Take a second and read to yourself what is in that little bubble or the little cloud, because sometimes people have never used one of these old school scales because a lot of times in this world now, stuff is digital. So we don't use these kind of balancing scales anymore. And they kind of don't make sense to some of us. So take a second and read that to yourself, and maybe that example helps you a little bit more. All right, so let's go down and talk about some inverse and how those work really quick. All right, so we recently talked about inverse and what inverse is. So really quickly, I want you to take a second and recall, what does the word inverse mean? If you recalled that the word inverse means to do the opposite, then you are 100% correct. If you did not, that's totally okay. That's why we're learning. So inverse just means the opposite of something. So the inverse of heads on a coin would be tails. Okay, so there are 4 blanks here. It says blank undoes addition. It also is reminding you that undoes means the opposite. So we're talking about the inverse of addition. What is the inverse of addition? Okay, I want you to take a second and fill in these 4 blanks. And then we'll talk about this and I will show you some examples. Go ahead and take a second. So when we say blank undoes addition, what is the inverse or the opposite of addition? Yes, subtraction. So what this means is that if we look at a problem that has a variable with then a number plus to it, remember that that number is called a constant, that we can undo that constant that's being added to our variable by doing subtraction. So if we look at this first example, this first practice problem, y plus 7 equals 20. If we look at that first example, I'm going to put a little yellow star in the corner so that you know it's the yellow one. We can see that because it has this plus sign here in the middle, we can undo that by subtracting 7. So really quick, let's make a table. And on our table, we're going to ask ourselves a couple of questions, and we're going to be able to solve this problem really simply. Okay? So the first thing that we're going to do is we're going to ask ourselves, what is the variable? And the variable is y. Okay? And we know the variable is y because it's right there. It tells us in the problem, our variable is y. And then we're going to ask ourselves, what's happening in this problem? Okay? And like we said, we are adding 7. And we want to make sure that we remind ourselves that we're talking about that plus also. Okay? We're not just 7. We are adding 7. But then if we know that we're adding 7, we can also ask ourselves, what is the inverse of what's happening? Well, if we know what's happening is plus 7, what is the opposite of plus 7? Subtract or minus 7. Okay? Awesome. I'm going to go ahead and clear all of the writing off of our problem up here. And remember I told you I like to draw the scale on my problems? That's what I mean. Just draw a line down the equal sign so that you can remind yourself that you need to do everything on one side of the equal sign. Anything you do, you got to do it to the other side of the equal sign also. Okay? So we have our plus 7. That's already in our problem. It's right there, plus 7. It's already there. It's already done for us. So we can check that off already. It's done. So now we need to minus 7. But again, what we do to one side of our problem, of our equal sign, we got to do to the other side of our equal sign. Well, 7 minus 7, that gives us a big, huge 0. And then 20 take away 7, that gives us 13. Give me 1 sec, I'm going to make this. So now that we know that 7 minus 7 is 0, all that we have left is our variable. So we're going to bring this y down, and we're going to put y, and we're going to bring our equal sign down, and we're going to say y equals 13, and we'll circle it because it's our answer. But we should probably check ourselves to make sure we're right. So we're going to check work. Okay. And we check our work by rewriting the problem. So we're going to, but instead of y, we're going to put in 13. So we're going to say 13 and then just plus 7 equals 20. And then now we actually need to add 13 plus 7. What is 13 plus 7? 13 plus 7 is 20. Does that in fact equal 20? Why, yes. Yes, it does. We're going to check it off because that's correct. So now we have that correct answer. So we have shown our work, we've done all the work, and we're ready to move on. Why don't you give this a shot with the next one? So there's the one at the top that says subtraction. I want you to try that one. You're going to do this one. And that goes with this problem. Give it a try. So we've got addition undoes subtraction. Super awesome. We already know that. We know that the opposite of addition is subtraction because we know that the opposite of subtraction is addition. So let's try this problem. I'm going to go a little bit faster this time, but I'm going to use the exact same steps that I used in the previous problem. I'm going to figure out what my variable is, but I'm going to use an abbreviation this time. VAR, variable. And my variable is M. What is happening? Again, I'm going to use an abbreviation, just HAP, H-A-P. And the inverse, INV, INV. Okay? So I know my variable is M. I know what is happening is that minus 5, because the problem says M minus 5, which means the opposite of minus 5 is going to be plus 5. So this minus 5 already in our problem. Done. Let's draw our line down the middle to remind us that what we do to one side of our equal sign, we have to do to the other. I'm going to add 5 to my negative 5, and I'm going to add 5 to my negative 3. All right. -5 plus 5 or 5 minus 5, that's 0. And then -3 plus 5 or 5 minus 3, that leaves me with 2. I'm going to bring down my variable and I'm going to slide down my equal sign. So m equals 2. And then I need to check work. And again, I do that by just rewriting the problem, but using that number that I got instead of my variable. So I'm going to say -3 equals, but instead of m, I'm going to put in this 2, and then -5. So now, using my understanding of adding different signs, I can say that -3 equals -3, and that is a correct answer. So let's give the last two a shot. The last two are asking us about what undoes multiplication. Well, division undoes multiplication. And multiplication undoes division. All right, so how you can tell that a problem is multiplication is that it has a number directly next to a variable with no space, no symbol in between. It's just a number and a variable smacked together, okay? How you can tell it's division is that it looks like a fraction. If it looks like a fraction, it is division. All right, so I'm going to go ahead and set these up exactly how I did the other problems, and then I'll show you how we do them. Okay, so I have our tables set up. Let's go ahead and jump in. Let's start with the multiplication one, this blue one. So this is 6 times x equals -42. So our variable is x. What is happening is it is x times 6. So remember that dot means multiplication. So times 6. And the opposite or inverse of times is divide. And we're going to divide by that same number. Okay, so we're going to divide by that same number 6. If you have to multiply or divide by a negative, you do the same number for your inverse. So if you're multiplying by a negative, you need to divide by a negative. It's not like addition and subtraction where you have to do the opposite sign. Keep your negatives with your signs. So if this is a -6 here, this would be a -6 here. But in this case, it's not negative, so we'll keep it positive. Okay, so in our problem, there's two ways that we can show this work. Up here, we can make this a fraction and write divide by +6 like this. This is how you're typically going to see it. This is how high-level mathematicians, this is how high school teachers are going to show you. This is the norm. If this doesn't make sense to you, it's totally fine if you just want to write divide by 6. I'm totally going to be okay with that. Okay? So now you just need to know what the answer is. 6 divided by 6 gets you 1, which leaves us with just x. And -42 divided by 6, well, that's going to be a negative and a 7. Bring down our equal sign. I'm going to go ahead and let you check the work on that one. Okay? So then let's look at our variable on the last one. This one is going to be multiplication undoes division. Our variable is W. What is happening is that W is being divided by 3, which means we need to multiply. Again, that dot means multiply by 3. So the way that we show this is that we put a dot on the side and we put a 3 like up towards the top because it really means 3 divided by 1. And then on this side, we also need to multiply by 3. So over here, because we get a 3 on the top and a 3 on the bottom, that gives us just 1. So we get W and equals, and 3 times -5 is -15. I'm going to let you check the work on that one too. And then I want you to try the U-try problems.